All right, this is a video over the practice quiz 4 material, just making sure we're ready for everything tomorrow. So we're looking at number 1 here, and it says find the number of distinguishable permutations that can be formed from the letters of the word Honolulu. Notice that this is different than just doing a straight number of letter factorial arrangement because there are letters that we cannot distinguish between them. Like I don't know if I jumble these up, which O is which. So the generic formula that we kind of use for this is that it's the number of items, factorial, divided by, well, the way I think of this is that you're going to have different factorials in the bottom, like R factorial, Q factorial, P factorial, and these are, each one of these stands for the number of times an item is duplicated. So that we divide out all of those times where we couldn't tell the difference between the two O's. So Honolulu has 8 letters, so this would be 8 factorial over, and then we have only one H, so if you wanted to write a 1 factorial you could, but that's not going to really change anything. We have 2 O's, so we're going to need a 2 factorial for the O's. We only have one N, we have 2 L's, and we have 2 U's. So we get 8 factorial over 2 factorial times 2 factorial times 2 factorial. If you have your calculator, obviously you could type all this in if you wanted, but you would need to make sure you put a parentheses around the denominator. If you want to expand it out, this would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Over each of these would be 2 times 1. So then we would notice that the 2 and the 1 here cancel. 2 can go into some of these other numbers, so 2 can reduce with the 8 and leave us with a 4. This 2 could reduce with the 6 and leave us with a 3. And what happens when you do this reducing is that now you have just a smaller number to multiply out, and you have a 1 on the bottom. So we have 4 times 7 times 3 times 5 times 4 times 3. And if we multiply all of that out, okay, so getting my calculator made my PDF crash. So we're doing 4 times 7 times 3 times 5 times 4 times 3. So that's 5,040. So there are 5,040 distinguishable ways to arrange the letters in the word Honolulu. Okay, looking at number 2. We get that the setup is that we have in a bag there are 6 green marbles, 5 white marbles, and 4 black marbles. How many ways can 4 marbles be selected without replacement? So that means we are keeping each marble as we get it if there are no restrictions. So if we have absolutely no restrictions, that means it doesn't matter. We're selecting 4 out of the whole group. And if there are no restrictions, we don't care what color the 4 marbles are. So essentially, you could think of this as just the total number of marbles in the bag, and we're going to choose 4. And the order does not matter. So this is 11 plus 4, that'd be 15 total marbles. So this would be 15, choose 4. And in a minute, I will pull up my combinations calculator and work that out. So we know we're not done with that one yet. Let's do the setup for B. It says we want 2 green, 1 white, and 1 black. So because we're doing these in succession, we're going to be multiplying our choices together. So we have that out of the 6 green available, we're going to choose 2. Times that by out of the 5 available white, we're going to choose 1. And we're going to have out of the 4 available black, we're going to also choose 1. So we'll have to work that one out. The next one is a little bit tricky because it says we want at least 1 white. So that means we're opening ourselves up to some alternative possibilities. At least 1 white, there's a couple ways you could think of this. You could actually figure out that that means 1 or more. And we could add together all the different choices that have 1 or more of the white. We could also do, remember, the complement, because we learned about in our set theory, is that in a universe, if you have a subset, the complement is everything outside of that that is still within the universe. So I'm going to show you two ways to figure this one out. So one or more could be one white, or two white, or three white, or all four of them are white. So if we do it this way, these are adding together these alternative possibilities. So the number of ways to choose one white is we would pick, we had 5 whites, so that would be 5, choose 1, and all of the other marbles in that group would come from the other 2. So this would be 6 and 4 would be 10, so that'd be times 10, choose the other 3 marbles in the set, plus if we wanted to do 2 marbles that are white, we would have to do 5, choose 2, and then we still have to complete the set. So out of our other 10 marbles that are a different color, we have to pick 2 more marbles. And then we would want to do 3 white marbles. So that would be 5. 5 white marbles, choose 3, times the 10 other non-white, choose 1. So notice this still makes a group of 4. And then for our final choice, the all 4, we would choose 5, choose 4. So we're picking all 4 of them. We're choosing them from the white group. So notice when we look at this setup, we're saying that you still have to pick 4 in each of these multiplication processes. So you have the white group, and then you have everything else. And we multiply those together. And then we're adding in between because these are alternative paths to meet this condition. At least one white could be this or this or this or this. Now this is, like I said, actually the more difficult way of doing this, because I'm going to show you in a minute that we could have done this by a complement. So let's go ahead and figure out some of these problems so far. So if I wanted to go back up, I need my combinations calculator. So let me pull that up. Okay, so since my calculator on my computer does not have a regular kind of choosing or permutation button, I always go to Calculator Soup for my combinations. It's just really easy. I just Googled combinations calculator, and it's one that comes up. So you put in your N and your R. N is, remember, the number of objects. R is the part that you are choosing for the selection of the group. So we're going back to the A part, and we're going to be doing 15, choose 4. And we get a total of 1,365. So 1,365. We could do this by hand the long way, but we're not going to. So we've got the second group, we're doing 6, choose 2, times 5, choose 1, times 4, choose 1. Anytime you choose 1, it's just going to be the number. So it's going to be 5 times 4 for that last part, but I'll go ahead and show you that the calculator will also give you that same information. So we need to do the first one, which is hang on just a second. There we go. 6, choose 2. So that gives us a total of, and the reason I do like this calculator is you can actually see they show you that they've worked it out as well. Whereas on your calculators at home, you just get kind of the answer. But see, this is plugging this into the formula. 6 factorial, you have the 6 minus 2 factorial and the 2 factorial. So this one is 15. And then we would do 5, choose 1, which I'm showing you is coming out to 5. I just want you to see that. And the reason is when you subtract 5 minus 1, you get 4 factorial. So pretty much everything cancels except for the first number. So that's 5, and the other one will be 4. So we have 15 times 5 times 4 for part B. And if we multiply that out, that's 15 times 20, which is 300. So now let's calculate this one, because I did this a different way than the answer key, because in the answer key for this, I went ahead and gave you guys the formula for the complement. So I'm going to show you that this is the same thing. So 5, choose 1 we know is 5. We need to do 10, choose 3. which gives us 120. So then plus, then we have to do 5 choose 2. And that gives us 10. And then we need to do 10 choose 2. Which is 45. And then we need to do plus, and then we'll have 5 choose 3. Which is 10 again. 10 choose 1 would just be 10. And then we have 5 choose 4, which is also going to be 5. Okay, so we're going to multiply and add all this together, and that'll give us our answer for at least one white. So we have 5 times 120 plus 10 times 45 plus 10 times 10 plus 5. And that is 1,155. Okay, and I did just realize that there is an error on the answer key, and you're about to see it when we do the complement, so I'm glad that I did this video. The answer for the C part, if you look at the back, it does not match, and that's because when I did not white, I counted 11 marbles and there were 10, which makes this 210, and that comes out to the 1155 like we have before. So we're going to go up and actually do it that way, but there is an error on the answer key, so make sure you are aware of that. So when we do the complement, the opposite of at least one white is no whites. We would want to take out the groups that have no whites in them at all. So the complement of at least one white is the universe minus the fact that we have no whites. So if you take the whole universe, which for us is how many ways can you just do 15 choose 4, which is all the different ways to pick any 4 marbles, and then you take out the combination where there were absolutely no whites at all, that will be the same as adding up this at least one white. So I'm going to kind of do this one kind of right below here. So this is an alternative method of doing this, and it's the one that I put on the answer key, except I had an error. So the universe would be all the ways to choose just any 4 of the balls, no matter what color they have. Okay, so this is called the complement, minus the fact that I have a group that has no whites in them. No whites means you only pick from the green and the black, so that would be 10 choose 4. And if you work that out, that's 1365 minus 210, which also gives me 1,155. So both of them give us the same answer. And then for D part, we have all 4 are the same color. So for all 4 to be the same color, that means you can't do all of those at the same time. You have to have options. So this is going to be alternatives. We're either going to be all green or all white or all black. So it's either going to be all green or all white or all black. So this would be just from the green. I still have to choose 4 marbles because our set is a set of 4. So 6 choose 4 plus means I could or do all white, which would be 5 choose 4 plus all black, which would be 4 choose all 4. Now I'm going over to my actual computer to do the combinations because flipping back and forth was driving me crazy. So 6 choose 4 comes out to be 15. 5 choose 4 is going to be 5. So that would be 5. And 4 choose 4 is you're choosing all of them. So there's only one way to do that, and that's 1. So this adds up to a total of 21. So if you do it that way, if you just do single, where it has to all be the same color, you have to do these alternative pathways. Okay, so that's the end of number 2. So let's go on to number 3. It says how many 3-digit numbers can be formed from the set 1, 2, 3, 4, 5 if repetition of digits is not allowed? So if you're not repeating digits, that means you could think of this as, since it's a 3-digit number, that means the order matters. Okay, so I could think of this, since on the first case, since there's no repetition allowed, you could do this as a shortcut of a permutation. You could say I have 5 items and I'm going to pick 3 of them. So 5p3. But if you didn't think of it that way, you could have made the slots. You're making a 3-digit number and you're not allowing repetition. So you have 5 elements. You can choose 5 for the first spot. You'll only have 4 left for the second spot and 3 left for the third spot. So that is 20 times 3, so there's 60 ways that you can do that. If you do 5p3, remember that's 5 factorial over 5 minus 3 factorial, which is 5 times 4 times 3 times 2 times 1. This is 2 factorial, so that's 2 times 1. And notice that gives me the same answer. So slots like this, the little spots, is really similar to doing the permutations. Now, if the repetition is allowed, that means that you can't do it by the permutation anymore, because permutations and combinations both do not allow for repetition of the object. So this would be have to do it by slots. So this means I have 5 elements, I have another 5 elements, I have another 5 elements. I can use any 5 of the numbers, any of the spots that I want. So this would be 5 to the third or 125. Okay, let's look at number 4. John needs to create 7-character password from lowercase letters of the alphabet, which means there are 26 elements there, and digits 0 to 9, which means there are 10 elements here. How many passwords can he create if the characters must include 4 letters followed by 3 digits? Now, they did not say that we can't repeat, so we're going to assume that we can repeat the letters and the digits. So 1, 2, 3, 4, 1, 2, 3. 4 letters means that I can choose any 26 letters for those first spots. So 4 spots, 26 letters each. 3 digits means I can choose 10 for each of those. So this is the multiplication principle. So this would be 26 to the 4th times 10 to the 3rd, which I'll work out. I'm going to use my calculator on my other computer since this PDF keeps wanting to shut down. So 26 to the 4th is 456,976, and we're going to times that by 10 to the 3rd. So that becomes 456,976,000. So 456,976,000. Okay. B part has some restrictions. It says a number other than 0 has to come first. So that means that we have 9 number choices for the first spot instead of 10. Followed by a vowel. Well, there are only 5 vowels that are recognized in the alphabet. We're assuming that Y is not being a special case here. Followed by a consonant. There are 21 of those in the alphabet. Followed by 3 digits with no restrictions. So that would be 10, 10, and 10, since we did not state that you can't repeat. And then another letter, which would be any of the 26 letters. So this is 9 times 5 times 21 times 10 times 10 times 10 times 26. That is 24,570,000. Okay, let's look at the next one. Alternate between letters and numbers. Now this is different. There's going to be 2 pathways here. Because there are 7 spots here, and even if there wasn't, you don't know if you're starting with a letter or a number, because they just said alternate between. So case 1 is going to be, what if we start with a letter first? Case 2 is going to be, what if we start with a number first? So we have 7-digit code, or 7 code. So 1, 2, 3, 4, 5, 6, 7. If you go with a letter first, that would be 26, then a number, then a letter, then a number, then a letter, then a number, then a letter. That ends up being 26 to the 4th times 10 to the 3rd, which we already know is 456,976,000. Okay. If you start with a number first, you get a 10, and then a 26, and then a 10, and then a 26, and then a 10, and then a 26, and then a 10. This is different for this case because now you only have 10 to the fourth and 26 to the third. So we don't know that one because that was not a previous answer for us. So 10 to the fourth times 26 three times is 175,760,000. Now, because this is two different ways to meet this condition they've set out, we have pathways or alternatives. When you have alternatives, it's an or situation, so we add them together. So I'm getting a total of 632,736,000. That is an insane amount of different passwords that you could create. Okay, and then our last example on the practice quiz is about collecting groups for a teaching assistantship. So we have 12 graduate students that have applied for 3 available teaching assistantships. And how many ways can the assistantships be awarded among these applicants if no preference is given to any student? So that's like having no restriction. We don't care if they're male or female. We don't care if one of them has a higher GPA than the other. So there's really not any order to this. We're going to be just selecting 3 people from the 12. So this will be 12, choose 3. And on my calculator for combinations, 12, choose 3 gives us a total of 220. If we have a particular student who must be awarded an assistantship, so this person for some reason must be included. So they're kind of like their own little group. So I always choose them first. I have one student and I'm definitely choosing them. You don't have to write 1, choose 1. You could just write a 1 here because that's what it comes out to. But if you want to think of it this way, that gives that a purpose. Okay. I have 2 other slots that need to be filled in this teaching assistantship. There's no order to who gets picked for them because we're just saying we need 2 more students. And we only have 11 graduate students left because this student has already been chosen. So we'd have 11 choose 2 more. So 11 choose 2 comes out to 55. And the 1 choose 1 is 1. So the last one is where we get into what if we wanted to separate the group into males versus females and choose specifically a certain number of males and a certain number of females. So the group of applicants needs to, now we know that the 12 people are 7 men and 5 women. It is stipulated that the placements must go to 2 men and to 1 woman. Notice the and in between there. We're going to be choosing 2 men and then 1 woman. So we're doing this in succession, so we are multiplying because we have to get the entire group of 3 people. So the 7 men, we're going to choose 2 of them times the 5 women, we're going to choose 1. So 7 choose 2 is a total of 21. 5 choose 1 is 5. If we multiply those together, that's going to be 105. All right, hopefully this guy will help you guys get prepped for your quiz, and let me know if you have any other additional questions.